All right, fun with the metric system. We thought we were done with this in science class, but we got to do it in math too, which is good because you need the reinforcement. So we're doing metric system, page 228, lesson 32. All right, let's give this a shot. The metric system is a system used primarily in most places in the world use the metric system, and to an extent we use it here, sometimes annoyingly here, like when I was fixing my car and I had to have two different sets of wrenches just to remove the alternator because some of the bolts were in what we would say the US customary system standard, or some were in metric, and that was really annoying. But I guess it gave you more opportunity to get more tools, so I guess I really can't complain too much. All right, so the key to the metric system is the fact that it uses the decimal system. So as we just did the decimal system, worked with decimal system yesterday, we've been working on it, and we're going to continue to work on the decimal system. You will get increasingly better at doing the metric system, and that's good. So let's take a look at some things today with the metric system. Okay, so let's talk about some units of length. So some units of length. So with these units of length, we have some things going on here. We have, for example, you know what? I want to backtrack. Let's not do units of length yet. I'm going to skip around in your book a little bit. I want to do metric prefixes. That'll be a little bit more helpful to start with. Metric prefixes, so you know what things are called. Okay, so if you make a chart in your notebooks, a 3-column chart, and man, I don't draw well. We'll title each column different things. So we have prefix, and we'll have unit in the middle, and we'll have the relationship on the right. Okay, 3 different things. So let's start with the first prefix, kilo. What we call that, an example unit, we're talking about length, would be a kilometer, or km. The relationship to that is 1,000 meters. So we are still somewhat doing length, but I want to just start with these terms. Hecto. You don't see hecto as much, but it's something that you should know. You have the hectometer. It's the easiest way to say it. Okay, that's HM as a indication, and it's 100 meters. Notice that we divided by 10 as we've gone down. So then we have deca, and deca actually does mean 10. So we have the decameter, which is DKM, and there's a reason why it's 2, and that's 10 meters, so we divided by 10 again. And of course, we have just the plain old meter. So we're talking about units of length, and that's indicated with a little m. Now we go to the decimal side of things, deca. So but you know your first decimal is in the tenths place, so you can pretty much guess where this is going to go. Decimeter, which is dm, and that is 1/10 of a meter. Centa, which means 100, is the centimeter. This is cm, and this is 1/100th of a meter. And then our last one, and there's a lot more, but we don't need to know them unless you're going to get into some advanced stuff later in life. Millimeter, mm, and that is 1/1000th of a meter. What's the cool thing about these is you can interchange these with different terms. If you're talking about volume, you would use the liter. Okay, so you can interchange these things to help you do different things. Now, if you want to talk about mass or weight, you would use the gram. So your prefixes all stay the same and the numbers all stay the same, just the word after it changes depending on what you're talking about. That's really useful because, as you know, when we look at the U.S. customary system, it's complex because an ounce in liquid is different than an ounce in weight. So they're different things, they mean different things. So this is kind of a handy, easy system. And if you look at it, notice everything, if you start from the top of the chart, working your way down, everything's increased or decreased by a factor of 10. So that can help you out. That can help you out with your relationships, with solving these things. And that's going to be really, really handy. So if I asked you the question, how much is 5 kilometers? How many meters is 5 km? You would say 5,000 meters, because 5 times 1,000 is 5,000. Or if I asked you 300 centimeters, 300 cm equals how many meters? You would say 3, because there's 100 centimeters in a meter. So it's really simple. Now, the one other key to this is there's a couple things you should know. The metric system and the U.S. customary system do not easily translate to each other, but there's a couple things that you should know. What you should know in metric system, 1 km equals about 6/10 of a mile. So when you go up to Canada and you start driving, you can realize that. A meter is about 1.1 yards, or about 39 inches, about, roughly. So I really should go more like this to indicate that. And one more that you should know is 2 54 of a centimeter equals about an inch.
I'm done with your kids.
Since I can translate back and forth, I can do a few different things. So what I mean by translate back and forth is 2 liters. Now I'm talking about volume, but it's just like when I was doing length with meters, liter, meter, kind of even it sounds the same, is 2 liters. If I want to know how many milliliters that is, thousand, how many thousand parts of that is, it would be 2,000, because the like milliliter equals 1,000 little parts of a liter. So I could easily figure that out. Now we're talking about mass and weight, then we're talking about grams. Mass and weight, then we're talking about grams to kilograms. That a kilogram equals 1,000 grams. Okay? So a gram is like a meter in that case, and 1,000 milligrams, 1,000 milligrams equals 1 gram. So that can also say, if I took some Tylenol and it was a 250 milligram tablet, how many would equal a whole gram of acetaminophen, which is Tylenol? Well, I'd have to take 4 of them, because 250 times 4 equals 1,000, which equals 1 gram. Okay, so pretty handy dandy stuff. Now, one more thing that's a little bit different in the metric system is temperature. And temperature is just a little bit different. So in the metric system, 0 degrees Celsius is the freezing point of water. Oops, misspelled that. It's the freezing point of water. And going all the way up, your body temperature in Celsius is about 37 degrees Celsius. Going all the way up, way, 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 way up, and I didn't graph this out very well. This is body temp. 100 degrees Celsius is water boils. So those are some key terms that you need to know, remember. And the translation of that is, that's 212 degrees Fahrenheit. This is 98.6 degrees Fahrenheit. And this is 32 degrees Fahrenheit. So as you can see, they don't translate very well across from each other. And there's a problem in your book that I just don't quite like, but it asks you this a few times, so I want to make sure you are paying attention to this. Is a temperature increase of 100 degrees on the Celsius scale is an increase of how many degrees on the Fahrenheit scale? Okay, so that's between 0 and 100. That's freezing and boiling. And on the Fahrenheit, that's 32 to 212. And 212 minus 32 is, anybody? Anybody? 180 degrees. So that means 180 degrees divided by 100 means there's an 18-degree difference. So every time, every degree, you can kind of look at it as 18 degrees, but it doesn't quite work out that way. So what I'd like you to do is on page 231 for tonight, try the practice A through G. Thank you.